In this lesson, you will learn how to relatively and numerically date a rock. First, let's talk about the difference between numeric and relative dates. A relative date is comparing two items. For example, in this image, you would say that this layer is older than this layer. This is an example of the principle of superposition, where sedimentary layers on the bottom are older than sedimentary layers on the top. Another example of relative dating is to say that Steve is the oldest student in the class, or to say that dinosaurs are older than mammoths. With relative dating, you compare two or more things. You cannot convey the meaning of the age of the rock or the item without this comparison. Numerical dating is also called absolute dating, and you will see it referred to in both ways. With numerical dating, you assign an age or a range of ages to an item. So going back to this image, we can say that the Vishnu schist is approximately 1.75 billion years old. Or we can say that Steve, from our example earlier, is 20 to 22 years old. Or we can say that the sandstone is from the Devonian period. In all three of these examples, you can get a sense of the age of the item without having to compare it to anything else. In this lesson, you will use both relative and numeric dating methods. One of the reasons we are concerned about dating rocks is to accurately reconstruct past geologic events. But we also date rocks to date the fossils found within the rocks. Fossils are important in reconstructing the history of life on Earth. From very early, simple one-celled organisms, to the first complex multicellular organisms, to dinosaurs, to mammoths, to primates, to humans. Fossils are evidence of past life. Some fossils are body fossils, meaning that part of the actual organism is preserved, like a dinosaur bone or the carbon from a fish. Other fossils are trace fossils. These fossils show past traces of life, but do not involve any actual parts of the organisms. Fossilized tracks are a good example of a trace fossil. You need special environmental conditions to form fossils. Generally speaking, an organism is best preserved in a low oxygen, low energy environment, especially if it has a high sedimentation rate. The beach that you see behind me is not an ideal environment for preserving fossils. The crashing waves are very high energy and would destroy most organisms before they could be preserved. This coral reef is slightly better for fossil preservation as the energy levels are much lower, but this is still an oxygen-rich environment, and most organisms will be decomposed by bacteria or eaten by scavengers before they can be preserved. The swamp you now see behind me is the best environment of these three options for preserving organisms. It is a low energy and low oxygen environment, allowing for organisms to be buried and start the fossilization process before being decomposed. As I mentioned earlier, fossils are used to reconstruct how organisms evolve through time. We will briefly look at evolution in the second activity of this lesson, but if you want to learn more about the history of life on Earth, I encourage you to take a historical geology or a paleontology class.